These are notes for section 5-6, graphing linear inequalities with two variables. In semester one, we graphed inequalities with one variable. And in semester two, we've picked up these things called linear systems. And so now what we're doing is we're going to combine the idea of inequalities with systems and come up with linear systems of inequalities in the next section. But first, we need to understand how to graph linear inequalities with two variables. And the good news is it's the same as graphing linear equations. I tried to make a line, I wasn't meaning to cross that out. And when I say same as graphing linear equations, of course, I'm talking about slope-intercept form. And we need to remember slope-intercept form being y equals mx plus b, where m is the number in front of x, and that is our slope of the line, and b is the y-intercept of the equation. So this is something that was discussed in Algebra 1. Hopefully, we've retained this knowledge. Now, there are some differences with inequalities to equations, and those differences come down to what the inequality sign is. If the inequality sign is less than or greater than, that means that we have a dashed line. And we can think of this like our open circle from Algebra 1, not equal to. It's a dashed line. If our inequality sign is equal to, less than or equal to, greater than or equal to, that means that we have a solid line. And you can think of that as our closed circle from Algebra 1. So that takes care of the line, and we have some examples below. And then if we remember from Algebra 1, if I do a quick example over here, if I had the inequality x is greater than 3, this is a single variable inequality. Well, I have positive 3 on my number line. It's not equal to, so it's open, just like I would have a dashed line. It's open circle. And then I have to shade one direction, meaning x is greater than 3. Numbers bigger than 3 are to the right. So I would shade to the right, 4, 5, 6, 7, 8. Those are numbers greater than 3. So when I have my linear inequality with two variables, again, I have to do some kind of shading. And if my inequality sign is greater than or equal to, you can think of this as shading up, greater than, bigger, more, shading up. And we'll do some examples below. And then, of course, if it's less than equal to, we have to shade down. And that's smaller, less than, down, less than. We're shading down. It's less than, shading down. And those are the differences between equations and inequalities. So let me walk through a couple of examples here. Let's zoom in so we get a nice picture on our graph. Again, using slope-intercept form, y equals mx plus b. On number 7, y is less than x. I have a slope of 1 and a y-intercept of 0. The number in front of x is 1. The number at the end of the equation is nothing. It's 0. Y equals mx plus b. So my first point's the y-intercept, and then I use the slope. Up 1 over 1. That's 1 over 1. I use my slope as directions to every other point on the line. And it's important that we graph all of the points using slope-intercept form. Now, if this were an equation, I would go ahead and just draw my solid line. But we're talking about inequality, so I have to look at the inequality sign. It's less than, not equal to, just less than. Well, if it's not equal to, that means that my line is going to be dashed. And now I need to figure out which way to shade. I either need to shade above the line. You can see we kind of have two sections of this graph. We have space above the line, or we have space below the line. And again, the shaded area represents the solutions. It represents the numbers that make it true. Again, you might say, what do you mean, make it true? Well, if I come back to my basic graph here, x is bigger than 3. The shaded area contains the numbers that make the inequality true. 4, 5, 6, 7, 8. All of these numbers make this inequality true. Well, it's the same thing in my graphs. I need to find the shaded region that has the points that make it true. Now we could just go pick some test numbers and try it out, or we could go off of if it's less than, that means that I am shading below the line. Everything below the line is an area, is a solution. Everything above the line is not an answer. And we could quickly see this by just picking some numbers. Like if I pick this ordered pair here, let me pick it in a different color. Maybe that'll help us out. If I pick this ordered pair, 0, 3, and I were to take this ordered pair and plug it in, well, 3 is the y value. Is 3 less than 0? Well, that's false. Clearly that's false. So that's not an answer. But if I were to come down here in the shaded region, and this is 0, -3. Again, if I were to take these values and plug them in, -3 is less than 0. Yeah, that's true. -3 is less than 0. So all of these points in this shaded region down here is going to make this inequality true. Just like x is greater than 3, all of the numbers in the shaded region will make the inequality true. On number 8, the slope is -1. The y-intercept is +3. I come up here to 3 and I put my y-intercept. And then I use my slope. Down 1, right 1, down 1, right 1. That's -1 over 1. This is my slope of the line. Algebra 1, Chapter 3, Section 5. I don't know what section. Graphing lines is what I'm saying. And again, if this were an equation, I would just make a solid line, but I have to look at my inequality sign. Greater than or equal to. Equal to means that I have a solid line. That's pretty good there, huh? Solid line. And now I have two sides to this line. I have a space above it, and I have space below it. I need to figure out which one I need to shade. And if it's greater than means up, as in getting bigger, that means I would shade above the line. Everything above the line is an answer. On number 9, you might notice that we're missing a, what are we missing? We're missing a variable. We only have a y. We don't have an x. So if we have a single variable equation, we can kind of throw slope-intercept form out the window. We need to remember that x equal a number makes a certain kind of line, and y equal a number makes a different kind of line. Well, x equal a number makes a vertical line, and again, this was all discussed in Algebra 1, and y equal a number makes a horizontal line. Well, I tried to make it horizontal. So on number 9, I have a horizontal line. Y is greater than -2, but this horizontal line needs to be dashed because it's not equal to. So I have a dashed horizontal line. Y is greater than -2. Greater than meaning bigger. Y is bigger than -2. Well, all of those answers would be up here. So you could either scribble like I do, or you could just put some arrows to say, hey, I'm shading up that direction. Doesn't matter. And number 10, let me change this example so I don't have to go through so many of them. Let's say number 10 is y is less than or equal to -1/3 x plus 2. So if my inequality has a slope of -1/3 and a y-intercept of +2. So my first point, I come up here at +2 and I put a point. After that, I use my slope, which is down 1, right 3, down 1, right 3, or up 1 and left 3, up 1 and left 3. I look at my inequality sign. It's equal to, so that means that my line is solid. I have a solid line because it's equal to, and it's y is less than that, less than as in down, down as in the side of the down arrow. And so from here, I shade down from the line. And again, you could either scribble or just put some arrows, which on the next section, we're going to use some arrows before we scribble. Hopefully that helps, and I'll see you on the next one. Thanks.